Alright, so for today, we are going to continue to build off every day's lessons. And today's not quite the last one. Today, we're going to do all the steps together. So we have a new example for us to do. It's going to review from day one how we do this. The new part we're going to add in today was, yesterday you guys drew your line of fit. We're going to learn how we take that line that you drew for homework, how we write an equation to represent it. And it's really pretty simple. So, we're going to do an example here, but when we do all of this, here was the steps that we're going to use. We're going to plot the points on our coordinate plane. We drew on our line of fit. Then what we're going to add in today is from our line of fit, that line you drew, you're going to follow your line and you're going to choose 2 points on that line that you drew. Not 2 points that are on the graph somewhere, but 2 points that are exactly on that line that you can identify. You're going to use those 2 points to find your slope. You're going to find out what your slope is. Then we're going to estimate our y-intercept, which is going to be pretty simple. And then we write our equation in slope-intercept form that we did last semester. Y equals mx plus b. The nice thing is, that is your slope, and this will be our y-intercept. So you're really only going to use 2 numbers. You're going to write y equals whatever your slope, x plus whatever your y-intercept is. So to help us, we're going to practice finding slope. If you open up your foldable, you should be on the part that says equations for line of fit. And you see it had this top part and it's just a big blank work area. That's because we're going to do an example of finding slope together. So I'm going to do number 1 with you, and then you're going to go ahead and do the second one. Remember, when we find slope, the most important thing is identifying our x and y. So I have -3, 3, and 0, -1. -3 is my x, +3 was my y. Everyone should be in there, so they're writing these down. My other coordinates were 0, -1. Those are also x, y. We always write our coordinates x first, then y. Because we have this one down first, -3, 3, it actually comes before 0, 1. So this means this one's our x2, y2. Remember, that little 2, all that means is, hey, this is the second point that just came next. To find slope, we do y2 minus y1 all over x2 minus x1. Hopefully that is sounding familiar to you, because we did a lot of that last semester in the 4th quarter. Now we're just inputting our numbers. y2 was -1. We're subtracting. y1 was a +3. x2 was 0, and I'm subtracting, and x1 was -3. When we solve this, -1 minus 3 gives us a -4. When we do 0 minus -3, well, what's a negative minus, or what's minusing a negative like? Adding a positive. So I'm going to change this to adding a positive. 0 plus 3 is 3. So on this first example, our slope was -4/3. And that's perfectly fine. We want it as a fraction. It's kind of easy. Rise over run. Okay, I'm going to give a sucker here in a second to see if you can do number 2. I'll help you out. This is x. This is y. This is x2. This is y2. I know this is not in your notebook. You have to write it down. Huh? Oh, you trying to solve it?
Yeah.
Oh, not yet. I want you to work. Remember, you're doing y2 minus y1, x2 minus x1. Ricky, I'll have you because you're up close. Go ahead up to the board. Can you do this?
This board?
Mm-hmm. Go ahead. So y2 is 4, y1 was 1, 4 minus 1. x2 is 2, x1 was negative 4, 2 minus 4, or 2 minus negative 4. He's reading as 2 plus positive 4. And leave it there. Okay, he got 3 over 6, that's correct. Can we simplify it? Yes. Who can come simplify?
He's calling you.
They did.
I pointed at him. You don't want to tip, it's okay.
Okay. Is that right? Yeah.
Kind of. Alright, the only thing that's wrong, this isn't negative, negative, this is equals. Oh. So,
It's also one.
just do this. These are positive. So, positive.
Yeah. Okay.
So,
Right, change it to 1/2.
you grab your sucker. Simplifying, your slope should have been 1/2. Not too hard to do this. So, we are going to try and go quickly through this whole process and get done with it today. So, starting from the very beginning, I went, not me really, but I'll pretend I did something. That's not good. I collected data to find out every year how many black bears are being killed on the road. So I took this data over 17 years of my life. I did this data. Alright, I guess I just did the research. But we found in year 1, 30 black bears were killed. Year 2, 37. Year 3, 46. So on. I have all my data in a table. I now want to find out, is there some kind of correlation? Is there a relationship to amount of black bears being killed as with the years progressing? So we're thinking, right now we're thinking, hey, we are probably going to have a positive correlation because someone's like, obviously, they think we should. And they can see our numbers big. We need to prove it. So the first thing we do when we go to graph a scatter plot is what? People that can walk me through my steps are going to end up getting the sucker part first. So what's the very first thing? Cohen?
You have to find your biggest number on the years and your smallest number.
Good. So I'm going to say this is my x. I'll say this is y. And you're telling me on years I have to find my biggest and smallest number. Why? What's that called? Do you remember? Yeah, it's our range. So my biggest number was 17. My lowest number was 1. So I'm going to do 17 minus 1 is 16. And then typically we would divide it by how many lines we have. We have 12 lines. So I'm going to kind of cheat on this one. I don't want to, if I did 16 divided by 12, I'd get 1.3 continuous. I don't want to skip count by 1.3. I don't really want to skip count by 1.5 because if I look at my x, it's going up by 1 every single time. So I'm going to go ahead and I'm going to skip count. I'm going to zoom in here. You can do this with me. Yeah, whoever just said that. We're going to skip count by 2. So here's 0. I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that's my x-axis, that's my scale. And if I'm being honest with you, me doing this to save time, right after I get done doing that scale, I'm going to label it. What is this 0, 2, 4, 6, 8? What's that represent? Years. So we're going to go ahead and write down years. Okay, so Cohen helped me walk through how to find my scale for my x-axis. What do I do next? Nathaniel? We're going to do the exact same thing for the y-axis. Now, can you walk me through it? Okay, biggest number was 129. Okay? And then 30 is my smallest. What am I going to do with those two, Hassan? Or Nathaniel? I'm going to subtract them. 129 minus 30. I'll do the math for you. That's 99. So once again, remember, that's called our range. We take our largest value and our lowest value. We subtract. We found our range. My graph needs to cover 99 for the data. So now what am I going to do, Nathaniel? Good. Divided by how many available lines we have, which was 12. 8.25. Nathaniel, this is still on you. Do I want to make my scale 8? Do I want to count out by 8.25? What do you want to go to? 9 or 10. We could easily go by 9. If you go by 9, yours is going to be correct. However, since 9 is really close to 10, 10 is a landmark number that's simple, we'd want to go to 10. So, I'm going to zoom in again. Ooh, what's the one thing I want to do different though? What's the one thing? I'll give this for a sucker as well. So you can remember this part. Daniel, that one's yours. Before I do this one, before I say 0, 10, Bryce? Nope.
No, I know.
Oh.
Andrew?
No, you're excluding the line.
Why? What am I going to put here?
The smallest 7.
Good. The very first line, I want to put my smallest term. Because it's going to be a jump. It's going to take up, to get to 30, it's going to take me 3 of my scales. So I'm going to put 30 there right away. 30. Do my squiggly. Remember, your squiggly is saying we left some information out. Alright, let's go ahead and put this on there. I'm going to pause. Alright, so we now have our scale. And I didn't have this recorded, so I'm just repeating myself. Charles told us that we had to put our label on our y-axis. These numbers going up on the y-axis represented how many black bears have been killed. And then I need to put a title on. So what do you think my title could be, Alejandra? Black bears killed. I'd probably say black bears killed on road. And instead of saying per year, the only reason is that would be more giving me a bar graph. This is I'm trying to find a correlation about black bears dying on the roadside. Huh? That's okay. Alright. What is the next important thing we do? Actually, I'll Alejandra, you can get this, you'll get the second, because you gave me the title. What's the next thing we should do? Good. Next, we're going to plot the points. Remember, here's our points, X and Y. X was 1, Y was 30. So I'm zoomed way too far. X is 1, Y was 30. I'm going to make these green. So I put my dot there. I'm going to pause my video. I'm going to go ahead and plot all my points. You do the same. And then you can look at mine. It's all in my head. Alright, so we've now plotted our points. I know I'm a little ahead of you, and that's okay because I'm going to keep going so we get through. But when you look at your plotted points, it should look fairly similar to mine. What do we do after we have plotted all our points? Usually it involves 4 things. Rylan? Nope. Tyler?
Find the correlation. You do the gap. You find the gap, and then find the cluster, and then you find the outlier.
Good. Then we're going to kind of look at our graph real quick. What is our correlation?
Positive.
It's a positive correlation. We were right when we first guessed. So I'm going to say positive correlation. Okay, let's talk about gaps. If I look at my dots, my data, it's going like this. Do I have any big gaps?
No.
No? So I'm going to say no gap. Okay, my information is going like this. Do I have any clusters?
No.
So no gap, no cluster. How about an outlier?
Yeah.
Not really. It's kind of tough, but that's that's when you don't have a lot of information. But if look at what my trend is, if I look at my trend, all the dots are falling right where I think that little trend line could be. So I'm going to say no gap, no clusters, or outlier. Now, this will be pretty helpful to me tomorrow when we go ahead and we're interpreting our graph, because I'm going to say, hey, this is a positive correlation with no gaps, clusters, or outliers. So I'm thinking my graph, it's kind of a steady change. So it should make me be able to make pretty good interpretations. Okay, who told me that? Did I already give you your sector? Oh yeah, it was Tyler. Okay, what do we do now? Brandon?
Make the line.
Yeah. Do you guys see how we've done every single day? We first looked at scatter plots. We worked on graphing. We've done that. Then we went from day 2. We identified the correlations. And the gaps, the clusters, the outliers. Yesterday, we looked at line of fit. So that is where we are at right now. So we need to go ahead and put our line of fit in. Will you and I have the exact same line?
No.
No. Because there's a little bit of interpretation. So I'm going to go ahead and try and put my line in for here.
Joe, where the rollers at?
No. What the heck? You're just saying
Yeah, I'm going to pause and let you guys do yours real quick. Alright, so here we go. We went and made our line of fit. So we made a line of fit. Actually, I don't like mine that much now that I look at it again.
Me either.
I kind of feel like my line of fit is. Let me take a picture of my phone. Okay, I'm coming in. I'm adjusting mine just a little bit. Alright. That's gonna be my screen. So, we have our line of fit. Now that we have our line of fit, yours might look a little bit different than mine. Now we're going to add the new part in for today. The new part is we have to write our equation. Good. We have to find out what our slope is. This is important because every class I've had someone ask the wrong or not the wrong question. That's a great question because they have a misunderstanding. They were like, well, let's use, I think in the last class he said, let's use 1288. I said, well, this 1288, if you use the exact point, was that on this line? To find our slope of a line, you have to use a point on the line. This is how I'm going to do it. I'm going to look at my line, and I'm going to start at the bottom, and I'm going to follow my line up until I have a place where I feel I kind of know the coordinate point. And for what we are doing, we're going to kind of go with our best estimate. So it might be a little bit off, but you'll see why we'll be okay. So like right here, I'm going to say that point I highlighted, it's kind of in the crosshairs between two grid lines for mine. Yours might not be that point. You have to look at yours right now. Look at how I'm doing it, but you have to apply it to your line. I can't say that enough. I'm going to keep going up on my line and the other one, it's pretty close there. It's on that one.
Yo, Mr. Sizzle, that's probably the best you ever get.
I'm going to say, to be honest, yeah, you're probably right.
That's probably the best you ever get.
For my line,
Oh, no,
oh, it isn't? For me, I'm going to say mine are the closest
There's not even a book there.
to right there. Well, it's okay. You don't have to have a dot there right now. We can add the dot. So Bryce is asking a question that he said, well, there's not a point there right now. That's okay. Remember, it's a line. Line is made up of infinite amount of points. So I'm going to identify this point. I'm going to do it in red just so we know that wasn't one of the points, but I'm putting it in there. Now, is mine exact? No. Okay? It's okay. I'm going to use my best estimate on this because I could easily just shift my line just a little bit to fit this. Once I have my 2 points, the next important thing is to write them down in order from left to right. So, from left to right, this first point was 6 and 50.
6 and 50.
That was mine. Look at your line. Your point might be different than mine. Write down your coordinates for your first point. My second point that I'm identifying is 860. Your points might be different because your line is different. Okay, so you have your line. So you're going to follow and find 2 points on your line. Some 2 points that you think you could tell me the coordinates on. So once again, look at your line. It'd be great if it did. Yeah, if it went through both. So you want to follow your line and say, can I find a point on my line that I feel like I know that coordinate? I then find my slope between those two. So 60, which was y2, x, y, x, y. These are the second ones. So 60 minus 50 for mine, 8 minus 6. I'm going to get 10 over 2.
Mine's 10
and it simplifies to 5. Just to show you why this might not be the same on each one. In this class, same graph, same example I've used in 4th and 5th hour. In this class, my slope is 5. In 4th hour, my slope was 4. And in 5th hour, my slope was, I think, like 22/5. So it changes just based off that angle that I make for my line. This is my slope. Okay, I want to cover the last thing. We have just a few more minutes, so focus with me. Hold on. Amen. I hope you're following in your notes and doing this with us.
So I'm the same as you, Mr. Chisel.
My equation we have our equation y equals mx plus b. The only thing I'm changing in this equation is the slope and the y-intercept. So for my answer, I'm going to say y equals, my slope was 5. So 5x. And then we're going to make our y-intercept very easy. There is a true way where we could find out the exact using equations, but we're going to just estimate. I'm going to go look at my picture. Remember, y-axis is up and down. Where do you think my line is going to be crossing my y-axis and at what point? The only problem, I'm going to give everyone a hint, we're going to use the same thing. Everyone's going to use about the same thing.
0.
Should be 0. We're going to make it 0. Even if it's not going to look exactly like it. And the reasoning is, when we crunch this down, it changes it just a little bit. We don't see exactly. Plus, if we look at our data is a little bit different than normal. Where I'm saying like shoe size and grade, or height and weight. This one's saying year 1, year 2, year 3. So if we would go back when we'd say year 2 or year 0, well, year 0, how many black bears would have died? 0. We didn't have it. So our y-intercept would be 0. You would say plus 0, or you just leave it off and say y equals 5x, or whatever your slope was. Y equals your slope x. Okay, before the bell rings, you have 2 minutes. I want to tell you what your homework is. I want you, for tomorrow, go back to your homework. You did your 3 graphs. 1, 2, and 3. For today, you did your 3 lines of best fit. You need to write an equation for each line, which means on each line, identify 2 points. They give you slope. If you want to use an extra piece of paper and just write it in there, that's okay.
Wait,
Yeah.
If we do word,
Yep.
You know,